Good afternoon, everyone. Thanks for being here. My name is Lui Guangpan from Indiana University and Purdue University in Indianapolis, from United States. Today, I'm going to talk about the phase equilibrium modeling and the prograde metamorphism and fluid events during accumulation of the Sommerard ecosite bearing eclogite in northwest India. First, let's look at how does an UHB eclogite form in a subduction background if the original rock being a mafic rock and being subducted to metal depths and appearance the ultra high pressure, it will come to the eclogites. As you can see the eclogites picture here. Calcite and microdiamond are indicated minerals for ultra high pressure conditions. As you can see, the calcite formation and the microdiamond formation depths here. Back to Himalaya area, if you look at the geology map, the dark area here is the Sommerard UHP terrain. Most part of this area is gneiss, as you can see here, the field picture. The dark area is the eclogite bonding, which is hosted as bonding inside the gneiss as the background, which is in light color. In this study, the eclogite sample we use is TM15. This sample were collected at the very center of this eclogite bonding. In this sample, it shows both the prograde and retrograde metamorphism mineral physics. For prograde, it has garnet, anthracite, fundite, quartz, orcosite, and luteal. For retrograde minerals, it has epidot, amphibole, and symplectite association minerals. We mainly use thermodynamic modeling to calculate the peak metamorphism conditions and also the fluid events in this study, mainly by constructing a series of those sections. The program for the modeling we use Soroka Domino, and the dataset we use is DSCD2. The major mineral AX relations for the garnet is from White 2007, and the other metabasite minerals mainly from the suggestion of Green 2016. We use a solid garnet in this eclogite sample, and we measured its composition using the EPMA analysis. As you can see, this measurement track, and this is the compositional profile. We separate this garnet and member composition profile into 14 steps to simulate the progress growth for the garnet. In this calculation, we also considered in the garnet fluctuation on the effective ball composition change. This modeling based on garnet isocompositional thermobarimetry give us the results of a fishhook shape clockwise prograde PT path. As you can see in this PT section, we got this prograde PT path. It has the garnet nucleation PT condition at 22 kPa and 537 Celsius. For peak pressure, it have 28.5 kPa at 533 Celsius. For the peak temperature, it has 613 Celsius at 24.5 kPa. The second part of this study is about investigating the fluid events during the eclogite accumulation. The first two microscopic pictures shows the fluids one. This phase of fluids is evidenced by the observation of 8.5 volume percent epidot and 29.5% amphibole. Those two minerals can form during the accumulation because they are not stable at the peak metamorphism. And these two mineral proportions are recalculated after excluding the garnet, prograde garnets. Core shows the composition of the glaucophene and rim shows the composition of baryosite. The second fluid is about the formation of the symplectite association that the minerals proteoclase, amphibole, and biotite. Let's first look at how to model fluid one. For the epidot formation, if you look at the point A in this pressure water section, which is at 610 Celsius, point A is the peak metamorphism. B is the phase in of the epidot. C is 8.5% epidot. That means from B to C, the apidote glows from 0 to 8.5% at the cut of Lothernite. See also the phase out of Lothernite. From C to D is the going to the floating in field. Now let's look at how to model the formation of amphibole in Flux 1. For this salination of this amphibole, if you look at this core and this section in the bottom left, it shows the decompression path drop from the floating in field to the point E, which is the saturation line. When it hit here, it's the amphibole core formed at 19 kbar and 610 Celsius with the breakdown of talc. If we look at the rim of this amphibole, it shows this point for the formation of this amphibole rim at about 14 kbar and 610 Celsius. Next is about modeling Flux 2 about the formation of symplectide association. We use this PT section to model the formation and PT condition of this reaction. We find in this modeling, it shows the reaction about clinopyridine and fungite and apidote formed to amphibole, biotite, albite, K-feldspar, and water. This reaction indicate the formation of the symplectide, which the PD condition is at 125 Celsius and 8.7 kbar. The fluid environment is formed in a very restricted fluid environment. Now let's look at the conclusions. The first conclusion in this study is about the prograde metamorphism PT path. We got the PT conditions with this garnet prograde glows for garnet nucleation, peak pressure, and peak temperature, as you can see here. They can represent the entire ecodite prograde PT path. The second conclusion is about we got two major phases of Flux event during ecodite accumulation. Flux 1 is about apidote formation at the cut of Lothernite and released 3.1 more percent Flux at 610 Celsius and 23.5 kbar. The formation of amphibole core on the rim from 19 kbar to about 14 kbar at 610 Celsius. Those water are from breaking down talc based on the modeling. The Flux 2 are about the formation of the symplectide around the anthracite grains. The PT conditions are about 625 Celsius and 8.7 kbar. That's all I want to talk. This project is funded by NSF and Merck Fellowship. Thank you all for coming to my Goldsmith conference presentation. Next, I'd like to take your questions.